Hey folks, today we're on three-dimensional figures, which is 11.1 in the Green Book on page 302. Three objectives here. We're going to identify, define, and classify polyhedrons by their characteristics. We're going to distinguish between regular and not regular polyhedrons. Then we're going to identify, define, and classify solid figures that have curved surfaces. So first, some definitions. So a polyhedron is a three-dimensional figure with faces that are all polygons. Each line segment where two faces meet is called an edge. The point of intersection of three or more edges of a polyhedron is called a vertex, which you've seen that before. Then a polyhedron with faces that are not all congruent, are all congruent, is a regular polyhedron. Obviously, if they're not all congruent, they are they're an irregular polyhedron. So, a few definitions for us here. All right, a prism is a polyhedron with two congruent and parallel faces called bases. So, right here we have a rectangular prism, a square prism, and a triangular prism. So, if we look here, this side is parallel to this side. They are congruent and parallel. This up top, this base, and this base below, they are parallel. Okay? This side right here is parallel to this side over here. Okay? I'm going to erase these so it's not so confusing. Okay? So all bases, not all bases, but the two congruent and parallel faces are called bases, and they are congruent and parallel. So right here, this triangle on the triangular prism is congruent and parallel to that triangle. Okay? Prisms are named by the shape of their base. So like right here, you would name this a rectangular because the base is a rectangle. This is a square because all of the bases are squares, so that's pretty hard. And then over here, this is a triangular prism, okay? Because if you set that up, okay, it would be on a triangle. It's just kind of at a weird angle. Let's see if I can move it. There we go. So if it was like that, it would be a triangular prism, okay? Okay, so right here we're going to go over the terms faces, edges, and vertex. Okay, so right here in red, my red here, this right here is a face. Okay, this is a face, this is a face, this is a face. Okay, those are all your faces. Okay, an edge. Okay. Let's do that in green. An edge is right here. Our edges here are in green. Okay, that's an edge. Remember, an edge is a line segment where two faces meet. So these are all our edges. Okay? So then we have a vertex. Our vertex, let's do that in yellow. If we can, hopefully you guys can see this. Okay, it's the point of intersection of three or more edges. So right here, do a little. This right here is a vertex. This is a vertex right here. We have a vertex over here. Here. Down here somewhere. Okay. So please make sure, and I don't expect this drawing here to be perfect in your notes, but try to do your best. I would use a straight edge to kind of just make some type of three-dimensional figure to label the face, the edge, and the vertex. Okay, or the faces, the edges, and the vertices. Okay? Okay. All right. A pyramid is a polyhedron with only one base. The base can be any polygon. The other faces of the pyramid are triangles. The shape of the base determines the name of the pyramid. So right here, we have a rectangular base, so it's a rectangular pyramid, right here. Then we have a square pyramid, because we have a square as our base. And then we have a triangular pyramid, which I know is kind of hard to see, but it does make a triangle right there. Remember, the shape of the base determines the name of that pyramid, just like it does with the prisms. Alrighty. Then we have our curved surface three-dimensional figure. So right here, of course, is a short nugget cylinder. Okay, we have a cone here, Let me have a yummy ice cream cone. Yum, yum. This is a sphere. And this is a half sphere, also called a hemisphere, right? Like when we talk about the Earth or any kind of shaped object, half of a sphere is a hemisphere. So with the world, we have a northern hemisphere, southern hemisphere, western, eastern hemisphere. Whenever you cut that sphere, kind of sounds like schmear, like schmear on a bagel, but it's not. But you know, half of a bagel is like is a hemisphere, so we could say like schmear on the hemisphere. I don't know if I'm making sense, but this is a hemisphere. I can't write. There you go. Okay. The last thing we're going to talk about here is Euler's formula. Okay, so for any polyhedron, if f is the number of faces, e is the number of edges, and v is the number of vertices, then f plus v equals e plus 2. So right here I just have a little a square prism, aka a cube, right here for us, and I've labeled it, I just put 6 faces. I can't really fill in 6 faces, but if I could, it would look kind of like something like this. And then down below. Okay, so 6 faces, 12 edges, and then 8 vertices. So all we do is we plug that into our Euler's formula. So there's 6 faces, 8 vertices, 12 edges. So we just do this, which is true. So this is a true polyhedron. Okay, so let's say that I only had vertices and edges. I could solve for faces, or if I had faces and vertices, I could solve for edges. Just like we've been doing the entire 7th grade year, plugging in those numbers and solving for a certain variable. Okay? Alright, that's it, guys. All I want you to do right now is do the 1 through 4, try these. Okay? 1 through 4, try these. Okay? I will see you all the next time that we'll be in class together. And yeah, good luck, guys. I'll see you soon.